Okay guys, now that you know a little bit about how scatter plots are set up and how they sometimes have a linear relationship and sometimes the points head in a positive or negative direction, it's time that we make sure we know how to actually construct a scatter plot. So first off, I want to point out that there is a typo. I think that it says something about a basketball goal. That should be just a basket. So basically the data collected in front of us is students on a basketball team stood at various distances away from the basket, so you can see those are given to us in feet, and they try to make a whole bunch of baskets in 30 seconds. So underneath in the chart you get the number of baskets that each person made. And what's a little strange is your data is involved in this table, but then there's another table below because there were more team members that also did the same data collection experiment. So please make sure that you understand these are the distances that you're going to be plotting in the chart, as well as the number of baskets for each person. So that means when we set up our graph, we kind of need to know who's X and who's Y. So remember, typically your distance is your X, and we're counting the number of baskets that they can make depending on the distance. So that's why we have our distance as our x-axis, in other words the distance from our basket in feet, and then we have our number of baskets made that's going to be along our y-axis. And then to divvy up the graph, it kind of fits nicely to go by fours, because I noticed that the highest distance that somebody stood was Tim right here. He stood 28 feet to get away from the basket. And then to figure out what kind of scale to set up over here, I didn't need to go all the way to 28, because if you compare just the numbers of baskets, I think Chris here is the one that had the highest number of baskets made in 30 seconds. So I knew I only had to go up to 14 on this scale, and it just fit nicely to go by twos. Again, down here, if you go by fours, you'll have enough space so that you can start plotting your points. So remember, each person's data becomes a point on your chart, just like we did when we put our graphs out in the hallway. So at 14 feet, Jared made 4 baskets. So make sure you put a nice visible dot for Jared. And then let's see, the next kid was at 22 and made 9. And then we have 27, which is going to be right over here. Whoops, and they made 7. 15, and he made 11, 26, he made 6. You can go ahead and pause and get the rest of your points on, and then play so we can continue to talk about our data. Okay, besides being careful about setting up your axes and your scales, it's always a good idea to double check that you've accounted for everybody. In this case, we had 10 team members, so we should have 10 dots. 9, 10, and I think I have all mine, so hopefully yours looks very similar. It's a very strange looking scatter plot compared to some of the ones we've talked about. We kind of have a little association going over here with these points right here. It seems to be that the farther they got from the basket, the less baskets they made, except for this person right there. Okay, that point is not really with the rest of the points. So what we're going to do now is we're going to talk about a little more vocabulary. We know that you can have a linear association when your points form a line. So I would say overall we do have a linear association, which means what we just talked about. As the distance from the basket increases, the number of baskets they made decreased. Therefore, we know this is a negative association, and that's what we talked about earlier. When you can line up your points and show which direction they're headed, this is definitely nice negative. So guys, here's some of that vocab I was talking about. If we have an outlier, we have a point that really doesn't fit with the other points. They're really kind of out on their own, and that's called an outlier. So that point we were talking about, if these points all kind of go in the same general direction and this point's kind of out in the boonies, that point would be considered an outlier. So out of curiosity, that would be the point 14.4. If you go back to your data, I'm pretty sure that was the first person who we got data for. So Jared is considered to have the point that's an outlier. The number of baskets he made was really a lot lower than the rest of his two teammates that also stood around 14 feet away. So we had a couple students that stood like 15 and 16 feet away, and their data was way up here. They were making a lot more baskets than poor Jared. So the other thing that we need to know about when we're working with scatterplots is, do you recognize when a whole bunch of points form a large group? If that is the case, we have clustering that occurs. Okay, we kind of have some clustering going on with ours. If you look closely, this area right here, we had a whole bunch of people that were standing the same distance away, and that all came within a basket or two of each other. And then technically, you could probably say that we have a cluster of data right here. There's 4 people who were standing at just about the same distance and that scored just about as many baskets as the people right next to them did. So we could say that we have 2 different clusters, and then we have this one little outlier in our data. And those pieces of information are really helpful to describe what's going on in the data that you have. So to finish up your notes, it looks like the group of players stood close to the goal, or I guess it should say basket. And another group of players stood far from the basket. And those are those 2 groupings of points we set out here and up here, which we could say are considered clusters. So, continuing on with our notebook, we have page 107 and 108 to tape these into.